In this video we're going to knock out examples 5 through 8, and each one of these we're going to take a rectangular coordinate like this one and we're going to change it to a polar coordinate. So if you remember your formulas, theta is going to be the inverse tangent of y over x, so that's 2 over 2, and then r will be the square root of x squared plus y squared. If we work with this one on the left hand side, I'm going to bring out our trusty calculator here so you can see how this happens. So we'll do 2 divided by 2, and we need to use the inverse tangent. We're looking for an angle, so we use the inverse tangent here. And this would be the radian measure, so it appears that I'm in the wrong mode. So just go to your mode button and go to degree. Now that would be an okay radian measure as well. I mean, you definitely could list that, but I think this will make a little better sense if we do this in degree mode, and you can see that it's 45. The tangent of 45 is 1 and 2 over 2 is 1. So theta in this case is 45 degrees, and r will be the square root of 4 plus 4 or 8, and so r is going to be 2 root 2. Remember, for an ordered pair, perhaps I should have done this with the r first, because the r is going to come first and then the angle measure will come next. So this is one possibility. Remember that there is an infinite number of ways to write a polar coordinate for the same location, and if you wanted to, you could also write this with radians as pi over 4, and that would work also. Either one's fine, but do know that you can write either one. Alright, we're going to move to example 6 now. So we've got example 6 here is convert 2 comma negative 3 to a polar coordinate. So we'll utilize the same thing here. And this time maybe I'll do r first here. So that's going to be the square root of 2 squared plus negative 3 squared. Keep in mind when you do square those values, you're going to wind up with 2 positives underneath here. So this is the square root of 13. Now what we can do is we can take the inverse tangent of y over x, and that's going to get us theta. So if we use our calculator, we can just type in the inverse tangent of negative 3 divided by 2 and go with that. Now you'll notice that this is a negative value here. We need to do a little bit of thinking, especially with these polar coordinates. So what I'll do for you is I'll draw a quick sketch of where this is. So this would be 2 and then negative 3. So this is definitely negative 56 degrees. If you wanted to use the positive value, all you need to do is add 360. And so this would be all the way around to 303. And we'll round to 0.7, I believe. So we'll do that. So 303.7 degrees. Theta is about that. And if we name our ordered pair, we would call this root 13 and then 303.7 degrees. One can also change this into radians. All you need to do is multiply your answer by pi divided by 180, and that gets you to about 5.3. So you could also list this as root 13 comma 5.3. When you don't have any value that's up here, that will be in radians. The next one is example 7, and we're going to convert this one to a polar coordinate. It's often a very good idea to write out where this thing is. So negative 3 and then down, up root 3 will be up here. So we're expecting this angle measure to be somewhere between 90 and 180, and then our radius, of course, here will be positive then. If we take a look at our r value, this is going to be negative 3 quantity squared plus root 3 quantity squared. If we do a little simplification, that's 9, that's 3. So r will be the square root of 12, which is also 2 root 3. To find out the value of theta, we can do the inverse tangent of y, which is root 3, over x, which is negative 3. If we type this in our calculator, we'll do second tangent, which will get us the inverse tangent, and then we'll do root 3 divided by negative 3. And that gets us to negative 30 degrees. Negative 30 degrees is actually right here, but if we list this as negative 30 degrees, comma 2 root 3, the point would actually be over here in this area. So we have to be very smart when the point is in quadrants 2 and quadrant 3. Anytime the point is there, you have to understand that your calculator will not solve for these quadrants. We'll only solve for these values right in here. So in quadrants 1 and 4. It's going to give you a positive angle measure from 0 to 90 or a negative from 0 to negative 90. So the range that the tangent will solve for is only negative 90 degrees up to and including 90 degrees on the positive side. So you have to be a little bit smarter and understand that the angle of this is actually not that. It's 180 degrees from that direction, so we need to add 180. That would get us to 150. So the real angle that we want is 150. Our radius will stay the same. You could have kept that negative 30 if you wanted to. You just have to make this negative, so that's definitely a way to do it. And then if we change this one into radian measure, we've got 2 root 3, and then the radian measure for 150 is 5 pi over 6. And that one will work as well. One last one here to do. We're going to take negative 5, negative 8, change it into a polar coordinate. So this is one of those ones where we need to be very careful. If we go left 5, down 8, we're going to be somewhere here in quadrant 3. So we're going to need to be very careful with our inverse tangent. Let's figure out r first. R will be negative 5 squared, or the square root of negative 5 squared plus negative 8 squared. So r will be the square root of 25 plus 64. That should get us to, I think, 6, 7, 8. So that'll be 89. To figure out theta, we'll do the inverse tangent of negative 8 over negative 5. And we'll try that in the calculator. So we've got negative 8 divided by negative 5. And we've got about 57.99, so we'll round this one to 58. If you'll notice though, 58 is right here, so we need to add 180 degrees to that. That'll get us to the actual angle measure. Once again, the calculator will solve for only negative 90 to 90 with the tangent. Those are the principal values for tangent. And then over here on this side, we need to be very careful and understand that the graphing calculator will not give us this one. It will give us 180 degrees from it. So this one should be 238 degrees. And then we're going to list our angle measurement here, or our radius first, excuse me. Square root of 89, comma 238. So that's one possibility. And if we wanted to change this into radians, well, we could do that as well. So we could just take our answer and multiply it by pi divided by 180. And we've got about 4.15 there. So approximately 4.15 would be your radian measure.